Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Hope you all fine. Lecture for grade 8, subject chemistry, chapter number 2, lecture number 10. And here is Mrs. Saira Jamal. Dear students, today we are going to start chapter number 2. What are the major concepts of chapter number 2? Means the topics which we will study in this chapter are theories and experiments related to atomic structure. Atomic structure, structure of atom. Yeah, like who's explain what are the scientists who give theories and they have done experiments about the structure of atom to explain the structure of atom. Then isotopes and electronic configuration we will study in this chapter. Introduction of chapter. Atom, you know, is very tiny particle, and as we are studying the atomic structure, so definitely you must know about the atom. Atom, although you learned in your previous classes, but it is very tiny particle. We can see it only with a special type of microscope called scanning tunneling microscope, not under ordinary microscope, not under electron microscope, but there is a special design microscope for the atoms to see is the scanning tunneling microscope. Atomic structure was explained by series of experiments. Many scientists they perform experiments and they try to explain the structure of atom. In 19th century, a British physician Rutherford and a Danish physician Neil Bohr was the student of Rutherford, and they determined the structure of atom. They have done work and many experiments on the structure of atom. Theories and experiments related to atomic structure. As I told you, there are many important theories about the structure of atom, but the most important theories are Thomson atomic model, which is also called plum pudding model or plum pudding experiment, Rutherford atomic model, and Bohr's atomic model. The first one, plum pudding model. The plum pudding model was an early and incorrect because this model was rejected by the scientists. So that's why it is called incorrect. 20th century model of an atom, and it was proposed by which scientist? J.J. Thomson. J.J. Thomson model showed an atom that had a positively charged medium or space with negatively charged electron inside the medium. Outside the circle is of positively charged. Like you can see this red color is positive charge, and inside you can see the charges which are the negatively charged, or these are the electrons. And in this image you can see he said that the outer covering is of protons. Like you can take an example of football, that the outer covering of football is made up of protons, and inside the air in football is like the electrons. Or if you have the pudding, so the pudding is made up of protons, and inside the plums which are disposed in pudding or embedded in pudding, they are the negatively charged electrons. As I told you, this plum pudding model was rejected by many scientists, and one of them was Rutherford. And then he presented his model called Rutherford atomic model. In 1911, Rutherford performed an experiment in order to know the arrangement of subatomic particles. Subatomic particles, you know, electrons, protons, and neutrons. They are called subatomic particles. Rutherford, he performed an experiment, and he was expected that when I bombard positively charged particles on this atom or any atom, so as the outer covering or the medium of the atom is made up of protons, so he expected that the positively charged particle will repelled by the positively charged medium or the outer covering or the protons, and all the particles must bounce back. This he was expecting. But actually what happened? Let us see in Rutherford experiment. Rutherford bombarded a very thin gold foil about 0.0004 centimeter thickness. Why he used the Gold foil. Rutherford used gold foil for his scattering experiment because gold is the most malleable. Malleable means we can turn it into thin sheet, or we can uh, convert the gold into thin sheets and thin tubes or thin pipe. So this malleability means that they are soft and we can turn gold into thinnest sheet. So he used malleable metal and he wanted the thinnest layer as possible. And the gold she used was around 1,000 atoms thick. Although he took the thinnest sheet, but still that thin sheet contained 1,000 of atoms. Therefore, Rutherford selected a gold foil in his alpha scattering experiment. So he used alpha particles obtained as he bombarded the gold foil with the alpha particles. So from where he got those alpha particles, he used alpha particles obtained from the disintegration of polonium. Polonium is a radioactive element, and from this radioactive element, he produced or he obtained alpha particle. What are alpha particle? Alpha particles are double positively charged helium nuclei. You can see the two atomic number of helium is 2, and when and it has 2 electrons in the outermost shell. When those 2 electrons are ejected out or lost by helium, then the ion which we get is called double positively charged helium nuclei because it has photons only. The 2 electrons are eject out. Most of these particles passed straight through the gold foil. Only few particles were slightly deflected. As I told you that Rutherford was expecting that all the particles will be bounced back due to the electrostatic repulsion of the positively charged alpha particle with the positively charged proton, but this was not happen. Actually, you can see most of these particles they pass through the foil and straight through the foil. Only few particles were slightly deflected. Slightly deflected means deflected with shorter angle, but 1 in million. If there are million particles, out of those million particles, only one particle is deflected at an angle greater than 90 degree. So from this experiment, he observed some result. Although he performed the same experiment on other elements as well, and he got the same result. So the conclusion which he drawn from his experiment are, as I told you, that he used the source of alpha particle, then the alpha particles they pass straight through the you can see this is the screen. Through the screen opening they pass and then they fall on the gold foil, and most of the particles they pass straight and then they strike the screen. Some or most of the particle they deflect at a shorter angle, but 1 out of million particle you can see is reflected at an angle greater than 90 degree. Okay, so this greater than 90-degree angle you can see is only one particle. In this image also you can see alpha particle source, then passing through two slits and then through screen and fall on the gold foil, and then you can see the scattering of light from this screen. Source of polonium. Source of alpha particles, you use polonium. Alpha particles, they come out through this small opening and then they fall after coming out from the opening. These alpha particles which have positive charge, I told you, the electrons are ejected out from the polonium. Disintegration, I told you that when we pass some radiation on any element, so the similar charges, they repel each other, and that's why you can say that the positive charges will separate out and the negative charges will separate out, and then they give us some new elements. So this is called disintegration. So polonium disintegration will produce alpha particles or double positively charged helium nuclei. From the source, the light passes through the slit and then it passes through the small opening on the screen, fall on the gold foil, and you can see the fluorescence on the screen. I have a small video, and this will help you to understand. You can see the light pass come out from the source passes through the two slits, then pass through the small opening of the screen, fall on the goal point, and then after passing through the goal point, you can see that most of the particles they are passing straight or deflected at a very short angle. You can see they are making short angle, but one particle it is making this. If it will come like this is an angle of 90 degree. But if as they are bouncing back or reflecting back, means that they are making an angle greater than 90. This is 90 and this is greater than 90 degree. So one out of 1 million particles, only one particle is reflected at an angle greater than 90. So what are the conclusions drawn from his experiment? Number one, Rutherford concluded that majority of the alpha particle pass straight through the foil undeflected. Why? Because most of the space occupied by an atom must be empty. The atomic structure, it has nucleus in the center and electron revolve around the nucleus. So the electrons are revolving around the nucleus in specific pathway, but the nucleus is present in the center. So he concluded that most of the space occupied by an atom is empty. I told you that you can consider the nucleus in an atom like a pea in a big football stadium. Just imagine how small is pea and how big is the football stadium. So you can imagine that most or only if the center is nucleus and electrons are at the side, but they are very small particles, and so the most space is empty. Most space of an atom is empty. The deflection of few alpha particles to angle greater than 90 degrees shows that these particles are deflected by electrostatic repulsion. Electrostatic repulsion means that charge is repulsion. The positive charges of alpha particles, they are repelled by the positively charged alpha, positively charged protons which are present in the nucleus. So due to that repulsion, what happened? The one particle it will deflect it at an angle greater than 90. Massive alpha particles are not deflected by electrons. The question arises that electrons are also present in the atom. So why the electrons, they show no effect on these alpha particles? So the answer is that electrons are very small particles. They are very tiny particles. And alpha particles or helium, double positive helium nuclei, they are big particles. So those big particles have no effect or show no effect on those small electrons, or those small electrons will show no effect on the alpha particles. You can take an example like if there is a stone on a road, a small stone, so a big car or a big bus or a big truck can easily pass on that stone without damaging that stone. So the same is the electron. Electrons are very small, 1438 times smaller than protons. So these massive alpha particles show no effect on the electrons and they are not deflected by the electrons. So these are the conclusions drawn by Rutherford from his experiment, and on the basis of these conclusions, he presented a new model. Because I told you, according to the board, according to Rutherford, he thought that the J.J. Thomson experiment or the Planck-Podin model, all the alpha particle must bounce back, but it was like it was against his expectation that most of the particles they pass straight and only one and most reflected at a shorter angle, but 1 out of 1 million particle is deflected at an angle greater than 90 degree. So on the basis of these conclusions, Rutherford proposed a new model, and he named it planetary model. Why is he called it planetary model? Because it is similar to the solar system. As in solar system, the planets revolve around the sun. Same is the case. He said that the electrons they revolve around the nucleus in specific circles or in specific shells. These circles are called orbit. He named those circles orbits. The which force help the electrons to revolve around the nucleus in circular path. There are two forces. We say centripetal force and electrostatic forces of attraction. Electrostatic forces of attraction mean that the negatively charged electrons are attracted by the positively charged protons in the nucleus. So why the electrons they does not fall down in the nucleus? Due to this attraction, there is a force called centripetal force. Centripetal force is a force which helps the particle, which helps the electron to revolve around the nucleus and it does not fall in the nucleus. So these are the two forces which are balanced. Centripetal force and electrostatic forces, they are balanced and that's why the electron continue to revolve around the nucleus in circular orbits. You can see in this image that most of the alpha particles they pass straight and or deflected at a shorter angle as they touch the proton at a side, so they deflected at a shorter angle. But those alpha particles which are going in the middle, they are deflected, they are bounced back or they are deflected at an angle greater than 90 degrees. The Rotary model of an atom presented by Rutherford, he said that positively charged nucleus is present in the center, like the sun, and the planets or the electrons they revolve around the nucleus. Centripetal force, I told you, centripetal force balance this attraction of the electron and the central proton, and that's why it does not fall down in the nucleus. There are two defects or problems in the Rutherford atomic model. What are those defects? Number one, classical physics suggests classical physics, branch of physics. According to that branch of physics, it suggests that electron being charged particle will emit energy continuously. According to classical physics, they said that the electron is charged particle, it has negative charge. So when it revolves around the nucleus, it must emit energy or it must emit radiation. So this must happen that the orbit of the revolving electron becomes smaller and smaller until the electron must fall into the nucleus and this would collapse the atomic structure. So the atom will collapse, the atom will destroy. If the electron will fall down in the nucleus, what will happen? The structure of atom will collapse. This is one of the drawbacks of the Rutherford. You can see he said that the electrons, it will revolve around the nucleus, it will come closer to the nucleus, closer, and then it will come closest and ultimately fall into the nucleus. So it will fall into the nucleus, what will happen? The structure of the atom will collapse or destroy. Again, you can see the electron is coming closer to the nucleus, is coming closer to the nucleus, closest to the nucleus, and ultimately fall into the nucleus, and this is the collapse. Collapse, the structure of atom will collapse. This is a drawback of Rutherford, but actually this does not happen. This does not happen because you learn that the atom can neither be created nor destroyed. This means that atom can be destroyed, which is wrong because according to the postulate, the atom can according to the Dalton's atomic theory, atoms can neither be created nor destroyed. Second, if revolving electron emits energy continuously, it should form a continuous spectrum for an atom, but a line spectrum is obtained. Spectrum, you know, when light passes through a prism, it is it disperses into different colors, and that dispersion or that color give us a spectrum. This pattern of color is called spectrum. So according to Rutherford, as the electron when revolve around the nucleus, it emits energy continuously, so it should give this smooth or plain spectrum. But when Bohr performed experiments, so he got line spectrum. You can see these spectrums are not smooth. These spectrums have line. Although there are two types, absorption and emission spectrum. Those of absorption and emission spectrum, inshallah, you will learn in detail in higher classes. But just keep this in your mind that this spectrum is smooth spectrum or continuous spectrum having no lines in it. But in these two spectrum, you can see the line spectrum or lines are there, which shows that the electron does not emit energy continuously or does not emit radiation continuously. So this is again the second drawback of the Rutherford atomic model. What was the first drawback? The first drawback was that electrons come closer to the nucleus, and when it comes closest to the nucleus, it will fall in the nucleus and the structure of atom will collapse. It means an atom is unstable. An atom is an unstable particle. Second, I told you is that when light fall on the prism, so it give a spectrum. This pattern of these pattern of color is called spectrum. The smooth spectrum having no lines in it is called continuous spectrum. Continuous spectrum we obtain only when an atom when the electron emit energy continuously. But if the electrons are not emitting energy continuously, so we are not getting this continuous spectrum. We will get the line spectrum. So Bohr is another scientist who I told you is a student of Rutherford. He performed experiment and he observed that the spectrum obtained is not a continuous spectrum, it is line spectrum. It means that the electron does not emit energy continuously. Coming toward the Bohr atomic theory, I told you that the drawbacks they are removed by or they are answered by his student named Bohr. Bohr answered the Rutherford problems and the problems in his model. In 1930, Neil Bohr proposed a model for an atom that was consistent with Rutherford's model, but it also explained the observed line spectrum of the hydrogen atom. Main postulate of this atomic theory are as follows. What are the answers or what are the postulates or of the Bohr atomic theory? Number one, the electron in an atom revolves around the nucleus in one of the circular orbit. Each orbit has fixed energy. So each orbit is also called energy level. We know that electrons revolve around the nucleus in circular orbit and each orbit has fixed energy. The orbit which is closest to the nucleus, you can see it is lowest energy orbit. Then the second one is higher energy orbit. Then the third one is highest energy orbit. It means that as the distance of the electron from the nucleus increases, what happens? The energy of the electrons also increases. Got it? Each orbit has fixed energy. The energy of this first orbit will be different, will be lower than the second orbit, and the second orbit will be lower than the third orbit. So each orbit is called energy level. The energy of the electron in an orbit is proportional to its distance from the nucleus. I told you, farther the electron from the nucleus, the more energy it will have. If it is present in the third shell, so definitely it will have more energy. If it is present in the third shell, it has highest energy orbit, so will have more energy. In the second, then higher energy, and in the third, it will have lower energy. So it depends upon the distance of electron from the nucleus. Farther the electron from the nucleus, it means this electron will have highest energy than the electron which are present in the inner shell. The electron revolves only in those orbits for which the angular momentum of the electron is an integral multiple of h over 2 pi, where h is Planck's constant, and the value of h is Planck's is the name of the scientist, and he gave this constant, and according to his name, it is called Planck's constant, and its value is 6.626 into 10 raised to the power minus 34 joule second. What is angular momentum? Momentum, you know, is the quantity of motion in a body. The quantity of motion in a body is called momentum. But if the electron revolves or it is moving or its motion is in circular path, so we will, and in circular path, you can see electron is making an angle with the center. So the motion of this electron, we will call it angular momentum. What we will call it? Angular momentum of electron. So the momentum of electron in circular path as it is making angle with the center, so we will call it angular momentum. The angular momentum of electron is an integral multiple. Integral comes from integer. Integer may be 1, 2, 3, 4, 5, so on. So as the shell in atom are also n is equal to 1, 2, 3, 4. So we will multiply for shell number 1, we will multiply this value by 1. For shell number 2, we will multiply h over 2 pi by 2. For shell number 3, we will multiply h over 2 pi by 3. So integral multiple, it depends upon in which shell electron is present. That number of shell you multiply with this value, okay, it will give you the angular momentum. Angular momentum of an electron is integral multiple of integer. I told you comes from integer, and integers are 1, 2, 3, depend upon in which shell electron is present. If it is present in shell number 1, so you multiply h over 2 pi by 1. If second shell, then multiply by 2, third shell multiply by. Light is absorbed when an electron jump. As I told you, the drawback of the Rutherford, who said that the electron emit energy continuously. So this postulate is the answer of that problem. That light is not emitted by an electron continuously. Light is absorbed or emitted only when an electron jumps from higher to lower orbit or from lower to higher orbit. That's why he got the line spectrum instead of the continuous spectrum. Light is absorbed when an electron jumps to a high energy orbit and emitted when an electron falls into a lower energy orbit. Electron present in a particular orbit does not radiate energy. If electron will remain in its orbit, so it will not emit or absorb energy. It will emit or absorb energy if it jumps. If it jumps, you can see if an electron jumps from lower orbit to higher orbit, lower orbit to higher, it needs energy. Okay, this man over here show that this electron need energy to go from lower orbit to high energy orbit. So electron absorb energy. This is called absorb energy or require energy when it jumps from lower energy orbit to higher energy orbit. An electron emit energy when it jumps from higher energy orbit to lower energy. You can see the direction of arrow from higher energy to lower energy. I told you number one is lowest energy or shell, then this one is higher energy, and the last one is highest energy shell or orbit. So as electron is jumping from the second to the first shell, the energy of second shell is greater than that of the first shell. The energy of the electron present in the second shell is higher than the electron which are present in the lower shell. So electron will emit energy or will release energy when it jumps from high energy orbit to lower energy. You can see this very energy. This arrow is for the energy, which is also called photon. Photon is emitted with energy, and E is equal to hf. You will learn it in the senior class, but this is Planck's equation. So the fifth point is the energy of the light emitted, or the energy of the radiation emitted is exactly equal to the difference between the energies of the orbits. As electrons is jumping from E2 means second orbit to E1 means first orbit. When electron jumps from second orbit to first orbit, you know the energy of the second orbit is greater than the energy of the first orbit or shell. So when you subtract the energy of the first shell from energy of the second shell, you will get the energy of the energy difference between the orbit. That energy difference is represented by del E. Del E means difference in energy of the two shells or the two energy levels or the two orbits. Where del E is the energy difference between any two orbits with energies E1 and E2. Any two orbits, that means E2 may be the fourth orbit and E1 may be the third orbit when electron jump from fourth to third or from fourth to one. So this may be any one, but E2 is the high energy orbital and E1 is the energy of the low energy orbit. Okay, so these are the two very important theories about the structure of atom. One was the Rutherford atomic model, and drawbacks present in the Rutherford atomic model are answered by Bohr. The first drawback of Rutherford, as I told you, was that he said that the electrons emit energy continuously. Classical physics, I told you, branch of physics. According to that branch of physics, they said that electron is a charged particle and it will release or emit energy continuously and it revolves around the nucleus. But Bohr said, and this means that the atom is unstable. The atom is unstable. If the electron will emit energy continuously, its energy will decreases, it will come closer to the nucleus until it will fall in the nucleus and the structure of atom will collapse. And this means that the atom is an unstable species or unstable particle. But according to Bohr, he said that no, it is not possible. Atom is not an unstable species. Atom is a stable species. It does not, the electron in an atom does not emit energy continuously. It will emit energy only when it jumps from high energy orbit to lower energy orbit. Okay, not continuously. If it remain in the same shell, it will not emit any energy. Okay. And the second one, Rutherford said that as the electron emit energy continuously, so if we get the spectrum must be continuous. But Bohr, after performing experiment, he got line spectrum instead of the continuous spectrum. So he concluded that the electrons does not emit energy continuously. It will emit energy only when it jumps from high energy orbit to lower energy orbit. And the proof of this is the line spectrum. The line spectrum is a proof of this problem or this drawback that the electron is not emitting energy continuously. Okay, the postulates of Bohr again. I told you that the first postulate of Bohr was that, which is the answer of the Rutherford problem or drawback, that the electron in an atom revolve around the nucleus in fixed energy shell, or the energy of that circular path is fixed. That's why those orbits are also called energy level, because they have fixed energy. N is equal to 1 has n fixed energy, n is equal to 2, n is equal to 3. What is the energy of these orbits? Inshallah, you will learn in first year the energy of the different shells of an atom. So, but just keep this in your mind that each shell or each orbit has fixed energy, so it is called energy level. Second point, the energy of the electron in an orbit is proportional to its distance. Again, I told you that the energy of the first shell is lowest energy, second is higher, and the third is the highest energy. So as electron is far away from the nucleus, more distance between the nucleus and electron, you can see more energy that electron will have. It means that electron which is present in the third shell, it will have more energy than those which are present in the second and the first shell. The third point, I told you that angular momentum, I told you quantity of motion, and angular, when electron revolve around the nucleus in circular path, so the electron is making angle with the center at each point. This is called angular momentum. Angular momentum value is h over 2 pi. If you want to find out for shell number 1, so you have to multiply h over 2 pi by 1. For shell number 2, h over 2 pi by 2 by 3, because it's an integral and multiple means multiply. You have to multiply integer with this value, and that integer depend upon in which shell the electron is present: first shell, second shell, third shell. Light is absorbed. This is again the answer. Yet electron is not emitting energy continuously. It emits energy only when it jumps from higher orbit to lower orbit. If it jumps from higher to lower orbit, it will emit energy, and when it will jump from lower to higher orbit, it absorbs energy or it needs energy. The energy of the light emitted is equal to the difference between the energy of the two orbits. If electron is present in higher orbit and it jumps to the lower orbit, so the energy which is emitted, it depends upon the difference, like how much the difference between the two energy is. That difference we represent by del E. Del E is difference between the energy of second, because energy of second shell is more than the energy